Hi y'all, welcome back. We are ready to finish knocking out this board. The rest of it's going to go pretty quickly, I think. I keep saying that and it doesn't, but so one of the things we're going to be installing is a little power transistor over here. Then we've got a bridge rectifier, and then we've got some capacitors. Probably going to put these electronics in last, or the semiconductors in last. So let's go ahead and knock out these capacitors. We've got two big 450 volt capacitors, and they go right here, and it calls for 100 UF 450 volts, but I had a couple of 150 UF, let's see if I can, 150 UF 450 volts, which they're going to be perfectly fine. They're just a little bigger than it's absolutely required, and you see plus and minus, and these little snap-in ones will go like that. And then, again, there's plus and minus. So we'll put that in like that. And come back in and solder those two big lugs there. And I want to look real quick. And another thing. Yeah, we're getting back to that ground plane deal. So I want to go ahead and make sure actually, you know what I'm going to do? I'm going to go ahead and heat this up just a little bit. And put just a little breath of solder on this side. Like that. Because we saw the problems we were having with those other parts, with the solder flowing through to the other side and making a good connection. And so I think pre-tinning that just a breath. Yep, that'll work right. It's going to help the solder flow through and connect the two sides of the board together. And that's probably not 100% necessary, but I don't think it's a bad idea to do that. So let's get, and since these are pretty big terminals, I'm going to let some heat get in it and then roll some solder into it. Because you can't see how good a connection you're getting on the other side once you get these capacitors in, because you just can't see them. So get a little heat in it. And then roll some solder in there. And then these negative ones are the ones that I really want to make sure flow good. And then get this one. Get some heat in it. Make sure the solder's coming in good, then flow some solder in there. Okay. So that's those two big guys. Then across the front here we have three 220 UF 400 volts. Let's get these three 220 UF soldered in place. And again, we have the same issue with this big ground plane, because they're going to go like this. So I'm going to come in and get my tip clean. I'm going to come in and didn't mean to fill a hole in. Get a little solder around the hole on this side so that when the solder comes through from the other side, it's got some solder to connect to. Okay, so we got, and the negative shows you the positives here, the negatives there, so I'm going to put those in. Whoop, go in the wrong direction. I'm going to put them in like that, and those over, and we'll put all three of these in. And when I was choosing these capacitors, I was making sure that the lead spacing was right, where it would line up with the holes in this board. And so the BOM that I will upload will have all the right part numbers so that the lead spacing's right, and you won't have to worry about that. Again, warm the board up first and get a little solder flowing on the board, and then bring the iron over to the pin or the lead, and then roll some solder in it. I think this board's made to use either snap-in or radial lead capacitors, so these holes are pretty big so that it will accept a snap-in. See, there's a pretty big hole you gotta run some solder in, so don't be shy about flowing some solder into the joint. And if I did accidentally get the board off camera, I apologize, but I think I've done a pretty good job about keeping everything where you can see what I'm doing. And like I said in an earlier video, probably the video after this one, I'll get the schematic out and we'll kind of go over the schematic and try to understand how it works and how all this is, what all these parts are doing. Yep. Let me flow a little more solder into that joint. know when I first started posting these videos, I thought that 6BM8 was a good beginner's project, but I honestly think this is probably a better beginner's project if you've never, worked with assembled things or done electronics much. Because the circuit board probably is easier to deal with than point-to-point wiring. And I don't know if you saw, I got this little magnifier that's a handy little thing, and it's got a little light on it. But it's also nice. You can like leave it kind of folded up like that and put it under the edge of boards to kind of hold things up while you're working on them to keep them level, so the caps are all level. And just this is a handy little thing to have just for reading some of the really fine print. I think even if you've got good eyes, you'd have a hard time and what did I do here? I'm sitting here talking to you guys and I screwed up. These are the wrong two caps. We're gonna have to unsolder these two and move them to a different place on the board. And I hope I don't tear them up, because these were the 2200s. So I looked down on the table and there was a 22 UF and I went, oh crap. I was talking away and not paying attention to what I was doing. But I don't think, especially given as big as these holes are, I don't think we're going to have a problem moving those over to another spot. So you need to be paying attention. I'm sitting here all worried about having the board on the camera and talking to you guys, and I soldered this stuff in the wrong place. Okay. That just goes to show you we all can make mistakes. And it's not the end of the world. So what we're going to do here, we're going to get since these are bigger holes, we're going to get a little screwdriver, and we're going to heat this solder up. We're going to put that screwdriver through the hole to open the hole up for sticking the lead through. And since the screwdriver's stainless steel, the solder doesn't stick to it. Yeah. Okay. And then we're going to get little snippers and cut off any little stalagmites, I guess you'd call them, sticking out from that side. Okay, let's make sure we get the right ones here. These are 22. Oh. Goes in that way. And then, here we go. Here's the other 22 UF. And they're in the right direction. No harm, no foul. We'll just go back to work here. So, you know, if you're working along and you realize you've made a mistake, it's not the end of the world. Almost any of this can be corrected with just a little. Let me push this. I'm going to push this capacitor up while I'm heating this lead up, so it's nice and flush. There we go. Get this one, trim everything off. And it's like nothing even ever happened. Okay. So that's our 322 UF, 400 volts. And then we have these 2200 UF, 12 volts. And probably gonna have to come in here and straighten these leads up a little. Probably have to come in and straighten these leads up a little bit so they'll go through. And I'm gonna clean the solder, smooth the solder off of them so they'll slide all the way in. And then same with this one. And that's what I was saying, these little flat jaw needle nose are really handy. They're just little jeweler's pliers. And these aren't even very high quality ones. But they're great for like straightening up leads when you make a mistake. And then see, now these are basically like the little snap-in capacitors. And we'll just pretend like we meant to do that. And then put the last one in. Bend the leads over. Then we'll solder these three little guys in. And I think we've got one capacitor left. And try to flow through enough solder. Like that. Yeah, that's one thing that you probably noticed was that the 22 UF 400 volt was almost the exact same size as the 2200 UF 12 volt. So as the voltage goes up for the same value of capacitor, the size gets bigger real quick. And that's why you don't just use like 400 or 500 volt capacitors for everything. And not only are they larger physically, they're also more expensive. And so that's why you nothing to trim off there. So there we go. Last capacitor is a, where did I put that little guy? It's a little, this is a 10 UF 350 volt. And it goes right here in the front. And the plus side is right there. It goes like that. And so you can imagine if I was trying to solder this with this, if I put this in first, it'd be real hard to get to that joint without touching that capacitor. So that's the reason we soldered all the resistors in first. And like if you don't see the joint getting hot, just touch a little solder to the iron and see it just instantly transfers the heat. Okay. So now we have two components left. We have this bridge rectifier. And I did get a, I think I'm going to use the bridge rectifier that came with the kit. I ordered the same value, and it's a lot smaller part. And I would have to bend these leads all up. Plus, I feel like this physically larger part probably has more surface area to help transmit heat. So I'm going to use this one. It's sitting here, and I see we got a problem there. We got a crooked capacitor. So I need to heat this up. And now it's straight. Okay. And this thing has spacing. It won't fit the wrong way. But if you get one that's not spaced like this, that's like the one I bought, like this one with the pins are even, they're marked where it says, yeah, see how it's marked? Plus and minus, and then the two center pins are AC. And any of these bridge rectifiers are marked like that. And we know that this is the ground because it goes over here to this big ground plane. And so it goes like that. And so we're just going to face it up like that. I know I sound like a broken record, but heat the board up first. When we get some solder flowing on the board, and then you move the iron over, just moving it over like a millimeter until it's touching the pin. And this is a pretty big pin, so you're probably going to have to put some heat in it. Which I know is the opposite of what you want to be doing with a solid state device, but it's a big pin, got to put some heat in it. And these things need a good connection because there's a lot of power going through these, because this is the heater current is going through this part, so we want to make sure we get a really good solder connection on this this bridge rectifier that's being used for the heater DC. Well, I did it again, guys. I wasn't paying attention and the battery pooped out with just a few solder joints left to go. But anyway, we were soldering these two pins, and these were the last two pins on this bridge rectifier, and we got it soldered on. And the last piece was this power transistor, and this little guy right here. And you can see I put it on a little heat sink. I'm going to go ahead and pull this off so you can see it. It's one of those looking kind of transistors, and it calls for an MJE 13009. Well, the kit came with an MJE 13007, which is a lot smaller rated transistor. And the B plus is running through this, and they basically created a 385 volt voltage regulator with these Zener diodes in this transistor. And so I went to buy one of these, the 09 version, and it looks like it's an obsolete part, which happens a lot with electronics. They change so fast. You know, you see these circuits and you go look up the parts, and you know, especially with IC chips and transistors, they don't make them anymore. And so anyway, I found some new old stock on eBay, and then I bought some of these a couple of these little heat sinks. Obviously you just need one of them, but this shape really worked well. You put a little heat sink compound on the back of the transistor, or you know, in here on the heat sink like that, and then slip it down on the transistor. And because it didn't come with this little heat sink either, but I thought it was a good idea to put something on here to help keep this transistor from getting hot. So, and then the board shows you which direction this goes, and you just where is it? Yes, these right here. Solder these three joints, and we're all done. So sorry I was like that close and didn't get the last couple of solder joints in, but I think y'all got to see 99.5% of this, and now we have this beautiful little power supply board all ready to go. So we've got the main board, it's all ready. We got the power supply board, it's all ready. We've got the chassis all drilled, painted, and everything. So now we're at the point where we're going to start assembling it, installing the transformers, and screwing everything together. The last little piece of the fab work, though, is the bulkheads. And so we'll probably do those. We'll probably mount this power board just so we kind of know where the bulkheads need to go and where the wires are going to go through them. And then we'll fabricate those bulkheads, and then we'll mount the main board and finish soldering everything in it. So we've probably still got 3 or 4, maybe 5 videos left. And so, again, I'm trying to do this very step-by-step and not jump ahead. And again, apologize for the battery going in dead. I need to watch closer on my little screen here in front of me, you know, what's going on with the battery life. But anyway, I hope you'll build one of these. This is a really cool project. It's a lot of fun. And if you've never built electronic project like this, is a pretty good beginner thing to work on. Again, if you are enjoying the videos, please subscribe to my channel. Please like the video. And we'll see you soon for some more Phono stage fun. Have a nice day.